Hello, everyone. So yes, today I want to go through the basics in programming with libcurl, the API. Pretty much a light walkthrough of the basics and how the API is constructed and how it works. And I hope that you feel comfortable enough to ask if you have questions. And so if you have anything during my presentation, feel free to just enter a question in the Q&A thing. And we can get to questions after the presentation, unless I can sort of merge it into the presentation here. So I think I'm going to talk for maybe, I'll try to keep it shorter than 30 minutes. So yeah, this is me. I'm Daniel. I started the curl project. That's my website. The photo here is actually my workplace here that I'm work at from home, and I sit here right now. So pretty much, I'm going to go through some basics about libcurl, the project libcurl basics, and then into how to do the first simple synchronous file transfers, how to get some information back or extract information from a previous transport or transfer, and a little bit just briefly about how to do concurrent transfers, because libcurl is also very good at doing multiple parallel transfers. And then a few slides and talk about how to work with a dedicated URL parser API that libcurl provides. And of course, the Q&A in the end, or merged into. So just fire away questions if you have anything. So this is curl. Curl, the name, is actually a lot of different things. So we tend to mix it up. So curl is started out as a open source project, right? So curl, usually with the uppercase URL and lowercase c, that's how we started to talk about the curl project. So that's how it started. And the curl project started to make the curl command line tool and libcurl the library. So they are sort of three separate things, but they're all intertwined a little bit, because the curl project makes curl and libcurl, and curl, the command line tool, is mostly constructed of libcurl, because libcurl is the library that sort of makes the network transfers for curl, the command line tool. So the question is there any relationship between curl on most Linux distros and libcurl? Yes, because libcurl, the command line tool, is just basically a wrapper around libcurl. So libcurl is the library that makes everything, all the network transfer stuff. So the curl tool then is, well, it's a client, it's an application that uses libcurl. So there are a lot of applications and devices and everything that uses libcurl, and curl, the command line tool, is one of those. So basically, we call it the product curl. I think it's quite a few years ago now, we changed the logo. So we have mostly just nowadays talk about curl using lowercase, but occasionally we use that original version with a few letters uppercase as well. The command line tool is curl. If you install curl on a Linux, on a Windows, on a Mac, or whatever, wherever you go, the curl command line tool is the same thing. It's this thing that we make in the curl open source project. If you, for any reason, fire up on Windows, if you go and, for example, start PowerShell, there's something else called curl, because they need an alias called curl that sort of sits in the way for you. So you need to use curl.exe instead. But it's still, we make curl, a lot of other people build it, ship it together with their operating systems or package managers and everything. So it's still the same curl, it's just a different pajamas, or different builds from different providers. The library is called libcurl. The libcurl library is it started actually in the 2000s. So it was roughly 2 years after we did the command line tool. But it's been around for a while. And today I'm going to talk about libcurl, that is using the API yourself, writing an application that wants to do internet transfers of some kind, usually HTTP or HTTPS, but I will get into that. libcurl can talk a lot of different protocols with a focus on doing transfers, uploads, downloads, getting data from a server, sending data to a server. libcurl is MIT licensed. It's actually not exactly MIT. It's actually often called as the curl license, but it's equivalent to the MIT. You can see it's just a few words that are different. And don't ask me why, but it's basically an MIT. So when do you use curl? Basically, when you want to use one of these, all of these purple boxes are different transport protocols, and curl supports them all. So when you want to do use one of those protocols to do transfers, uploads, downloads, get data, send data, libcurl is typically a pretty good choice because it's fast, stable, easy to use, and it runs and builds for pretty much any platform you can imagine. We actually count, I think, 101 operating systems that curl has been running on at some point. It has a lot of features. So not only does it support all those different protocols, it supports a lot of different features within all those protocols. So you can do, well, you can tweak your transfers and make those transfers do what you need them to do for your particular use case. And of course, it's used in a lot of places. We estimate that libcurl is used in roughly 20 billion installations today. In all these images on this slide are actually devices and things that are using libcurl. So it is in a fair amount of places. Lots of users have figured out that using libcurl is a pretty good, convenient, efficient way to do internet transfers for anything really. So the basics of doing libcurl stuff. First, of course, you need to get libcurl. libcurl is typically provided and exists as packages on, for example, Linux distributions. Usually it's called just libcurl-dev or something. Whatever distro you have, I'm pretty sure, or have or use, I'm pretty sure that there is a libcurl development package you can download and install. If you're using Mac OS, you can get it from Homebrew or Mac ports or on another package manager, or pretty much anything. You can also build it yourself from source code. It's really straightforward. Get the latest source code tarball, follow the instructions, build curl, and use libcurl. You can build libcurl using the classical Unix style configure, or you can go with CMake, and you can use, if you're on Windows, you can use the Visual Studio, the Microsoft compiler. So there are several different options to go to build curl. And when you build curl, build curl yourself rather than getting it from your package distributor, you have the option to also enable, disable, for example, particular protocols, particular features on, off, so you can streamline it quite a lot. You don't have to go with everything enabled style that usually package managers provide. For example, if you're only interested in doing FTP transfers, you can actually disable the support for all the other protocols just to get a little, maybe a little bit smaller footprint or just more focus in your stuff. You can also then, when you build yourself, you can also, in several cases, enable, disable, and select what kind of third-party libraries you want to use. For example, which TLS library do you want, which SSH library do you want, and what compression libraries do you need, and stuff like that. So you can select quite a lot from a lot of different things to make libcurl into the libcurl you want to use. And it cross-compiles easily, so you can cross-compile it on a regular developer machine for your particular target operating system, a particular target really. And of course, when you want to use, so you install libcurl and then you want to just build your application, and it's really, really straightforward, right? You tell the compiler where are the include files and how do you find the library. So typically, when you've installed libcurl in your Linux distribution, you just use the compiler, tell it to link with libcurl, that is the -l option. Use the library, it's called curl because it's the lib is implied, right? So -l curl, the source code and just output well, this creates a binary called example from the source code called example.c. So it's pretty straightforward. I'm not going to talk much more about how to build stuff because I imagine most of you already know how to build stuff. As I mentioned, then you can get libcurl from your package manager. You can build it yourself. Maybe someone else build it for you. You can see that there's a potential for many different libcurls here, because not only can you sort of tweak it in many ways, we also ship new versions, right? We ship new versions typically every 8 weeks. So we have a new version every now and then. We had a new version yesterday. So if you install it from different sources or at different times, you might get different versions. You may run it on different platforms. As I mentioned, it runs on virtually anything, so you can install it for pretty much whatever platform you have or you can imagine that you have. But you can then also toggle the features, and you can have different backends and different third-party libraries. So they're just if you go with one libcurl in one place and another libcurl in another place at a different time, they may differ slightly in what kind of features they allow and have enabled and everything. Just be aware. Just facts. So there's an API for everything pretty much to figure out exactly the state of your particular libcurl. And the documentation for libcurl, how do you figure this out? Apart from listening to me blab about things, we take documentation really, really seriously. And I really hope, and I actually think, that you will find libcurl to be a very well documented library and project. You can find anything and everything documented with quite a lot of details. And if you can't find the details, file an issue and report it, and we will add the details so that we have that documented going forward, because every function, every option has a man page here. So we're talking close to 500 man pages in libcurl now, and all of them, of course, are available on the website. All man pages for libcurl have examples. It's a mandatory thing for all our man pages, and actually all the examples are even we even compiled them in the test. They are test compiled, so we know that they actually don't cause compiler errors. We haven't, I mean, they compile. We can't actually verify that they actually do the right thing. So anyway, I'm just saying that we make a big effort to make sure that we have documentation. There are actually more than 130 standalone examples in the tarball and on the site, in case you want to just base your stuff on an existing example or read a full example. How do you do blah, blah, blah. And there are a lot of examples available. All man pages and all the documentation is always available on the curl website, of course. And there you can always find the latest updates on all these documentation, because of course we find errors, we add things, we clarify things, but the most updated versions are always available on the website, as well as in the tarballs and everything, right? So and they are also available as man pages in most. So if you install it on a Linux distro, for example, you may install the man pages locally on your machine as well. We also have this book called Everything Curl on everything.curl.dev, which is a full online book, a huge resource which tries to document everything in a more of a tutorial-like, describing how to do things more than just a reference guide. So as you can see, there are a lot of documentation opportunities and availability to figure things out. And whenever you want to just learn something about a particular function, for example, a particular libcurl option, just Google that function name or the libcurl option, and you will most likely find one of the top sources will be the official documentation for that particular function option. So that's it. Going forward, we have, of course, an API and an ABI. The ABI, of course, being the binary thing after you compile it, so API being the source code version of the same thing. And we make a really, really strong, hard effort to not break API or ABI for users. We're moving forward, we just add stuff. We don't remove stuff. We don't change. We don't break users. We don't break applications. Well, not willingly or knowingly, at least. So you can be fairly sure and safe that upgrading to the latest libcurl, that should always be safe. You should always be able to do that without breaking anything. actually, most of the code we wrote in the early 2000s, you can still just, run the same examples with the modern libcurl 24 years later. We actually, well, yeah, so the features, they remain. We've actually bumped the SO name. So a few things that we did before 2006, you cannot actually use today. But since 2006, every application you wrote can still upgrade to the latest libcurl and they will work. Caveat some edge cases, for example, if you would use old TLS versions back in 2006, they are not working these days, but not because of the API or ABI, just because the internet has sort of moved on since then. It's a lot of that, of course. Sometimes it doesn't matter if curl doesn't break anything, the surrounding can still make things break. And what is a really good and convenient thing is that it works the same on all platforms. So it is a very convenient way to allow developers to, for example, you can write your application roughly on Linux and then move over the logic to another platform and it'll just work the same way, which makes it sometimes easy. And it's also easy to, when your project moves from one target to another target, the libcurl using parts can just move over and live on. We have a few different well, API sets, I call them here. They're sort of families, API families, groups. So we sort of group them. There's an easy interface. We prefix those functions with curl_easy. We call that the easy interface. It's a silly name, but I called it that originally just because it was the easy. It was meant to be the easy way to do transfers. The name stuck. It's a little bit silly, but still. So nowadays we call it the easy interface. It's just a name. It's not always very easy, but we call it easy anyway. And there's the multi interface, curl_multi. It's for doing multiple concurrent transfers. It doesn't have to be multiple. It could still be one, but it's an it's a non-blocking API, whereas the easy transfers are a synchronous blocking API. I'll show you in a second. We have a share API. We have a URL parser API. So basically different sets of functions for different. We have a few others too, but this is just the beginners. We're only going to get into the basics here. So the API principles is basically you set up and perform transfers with libcurl. It's made to do transfers. So upload, download. You operate with a URL. You get stuff from a URL, you get stuff to a URL, and you that's what you do. And you send and receive data basically with callbacks in libcurl. The other end, the one you're sending data to or getting data from, is always a URL. That's the URL in the name, right? The curl name, that's the URL part. It's always a URL. That's the only mandatory option for a transfer. You need to specify the other end. The other end is always a URL. Also, transfers with libcurl are always basic by default. It really doesn't add a lot of bells and whistles by default. It will just do what you ask it to do and not more. So it'll do the basic stuff, and then you enable much more with options. And the API is, I call it largely protocol agnostic, because you typically don't have to know a lot about the underlying protocol or anything, and you usually don't have to care about it. If it's HTTP or FTP, you specify your URL, you specify where you want the data written or how to read the data to send to it, and then off you go. You don't need to figure out things about how the protocol actually works. Mostly. In some cases you need to, but usually you do that optionally. You want to do things, you want to fiddle with it, you want to improve it. And if you know stuff about the protocol, you can certainly understand more of libcurl and maybe use it even better. But you usually don't have to understand a lot about network protocol stuff. And you change behavior by setting options. So when you create a transfer, you get a basic transfer by default. libcurl offers a busload of different options, toggle, tweaks, options, and you can change things. If the default isn't good for you, there is going to be a whole slew of different options that you can fiddle with to polish, improve it. The easy interface, or transfers in general in libcurl, it works with easy handles. It's this curl uppercase pointer. That's just an opaque handle. There's just a pointer to something, compared to the file handle, file pointer in when you want to do open files, for example, in a C program. We refer to that as an easy handle. It's a handle to a transfer, a single transfer. So you create one of those handles. That handle identifies a transfer. You can reuse that handle. If you do one transfer with the handle, you can do a follow-up transfer after the first transfer, and then you do the third transfer, the fourth and fifth. You can just move on and on and on and reuse the same handle. But it's still always just one transfer at any particular moment in time. And when you have created one of those easy handles, you set options. The options then remain set until, well, until you kill the handle or you change the option again. They are sticky. You set it there and they will just remain there. And the options, if you set, for example, string options, if you set the URL, it will libcurl will copy the data, so you can reuse the memory after you tell curl that you set the data. And as I mentioned briefly, the URL option, curl opt URL, that's the only mandatory option. That's the only thing you actually have to set in an easy handle before you do a transfer, because otherwise it doesn't know what to transfer. I mean, what to communicate with, what the other end of the transfer is. The transfer always has a local end and a remote end, right? Or the remote end could be local as well, but you know, two ends. There's a transfer, the source and the destination. And curl always has a callback sort of centric interface, which means that you tell curl a function to read data from and send data to, for example. You provide function pointers to curl. All those options are named something on curl opt blah 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 function. And you provide a custom pointer to that callback if you want to, called something curl opt blah 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 data, which then is just a pointer from your application passed into the callback. So you can pass in private data to the callback, for example, a pointer to one of your structs or something like that. And then libcurl calls that function, the callback, whenever it needs things done. For example, there's a read callback. When you want to do an upload, curl calls the read callback to get data to send to the remote URL. Or the other way around, when you want to download something, you download from a URL, and curl will call the write callback from curl's point of view. That's write the data. Then it invokes your write callback. You save the data somewhere in memory on disk or throw it away, and tell curl you're done, and curl will continue downloading, writing, downloading, writing. And yeah, don't call libcurl functions back from within your callbacks, because that's crazy. Then you get some weird recursive stuff that's could triggers nasty stuff. Actually, nowadays, most functions will actually return error if you try to call them from within callbacks. There are some exceptions. You can call some functions recursively, but they are documented to support that. So then you will know. So basically, you should remember that the easy, or actually all, well, to do transfers with libcurl, you use these opaque handles that point they're just handles. They point to something. You just pass that pointer around. There, you need the URL. The URL is the source or the destination of all transfers, and you have callbacks, one or many callbacks. Typically, you actually have a set of callbacks for any particular transfer, depending on what kind of transfer it is. You most likely have at least a read callback when you want to upload, and you most likely have a write callback when you want to download. So that's sort of the basic stuff of easy handles and setting up transfers. So the easy interface, yeah, that's the silly name I was referring to. That's the easy interface does file transfers, internet transfers in a synchronous way, blocking. It performs the transfer until the end, when the transfer is completed, whether it's completed without errors or aborted prematurely because of an error. But it will do it. It will go all the way and then return the result to you. Did it work? It did not work. And it, by default, it will just do it as fast as possible, which could, of course, be very fast in some situations, very slow in some other situations, depending on all the different, all the factors, bandwidth, latency, equipment, hardware, the server, all whatever you compete with on the network and stuff like that. But the default behavior of the easy transfer is just do it as fast as it can, which actually, if I may say, should be really, really fast if you're not bandwidth constrained. But of course, it might take a long time. I mean, if you're downloading a huge file from somewhere and you have a very limited bandwidth, then the transfer might take a very long time. And by default, the libcurl will just keep on downloading, right? It doesn't matter anything to libcurl if it takes weeks to download. It's still fine. It works the same way. But you can, of course, configure that. You can tell libcurl that it should be done within this amount of time, otherwise it should return failure. Or you can also say, if it's slower than this for this amount of time, return failure, or stuff like that. There are a lot of options for you to tweak it to make sure that maybe 2 weeks is a little bit too long for your transfer. So set a maximum allowed time, 2 weeks, no longer than 2 weeks. So you basically create an easy handle. I mentioned that. And the way to create an easy handle is curl easy init. It returns a handle, and the handle is just a pointer, right? A pointer to an object that you don't know anything about. And it gets initialized to a bunch of default values. So it'll make a default transfer, and you can't extract anything. You can't read anything from that struct. And you clean it up again once you're done with curl easy cleanup. So that's the init and the corresponding cleanup when you're done. But of course, you want to do something with it in between too, right? Because it's not quite done. So you're in it and you want to set some options. And then you just do curl easy setup. Setting options. So you set options in this case, and in the example here on the screen, curl opt URL, set the URL to work with, https://curl.sc. That's the C string. That's the URL we want to work with. By default, a transfer is a download unless you set something else. So in this case, we don't set any other options. This is asking for a download of this HTTPS URL. And of course, the setup function, curl easy setup, is you can actually has over 300 options. So you can set a lot of different things, and they accept different argument types in this third argument. In this example here, you can see it sets a string, which is the URL. But you can also set integers for timeout values and other things. There are a few other different types depending on the option as well. So you really, to figure out how to set the curl opt URL option, for example, there's a dedicated man page for curl opt URL. You can read all about the curl opt URL in that man page. And all the other options have dedicated man pages as well then. So that is how you, of course, learn all the specific details about the specific options you want to use. So you can set the URL, you can set the verbose option, which is a very handy one, just makes it more talkative. So it helps you debug what is happening. It'll talk, will output a lot of stuff on standard error by default to tell you about what it's doing and what the protocol is doing underneath. You can set a buffer size, which tells libcurl how big transfer buffer to use, which might be useful if you want to do faster, for example, transfers where you're not as network bound. For example, if you're doing local host transfers, a larger buffer size will make the transfer faster. Error buffer, you want to get better error messages back, provide a buffer to libcurl to store the error message for you. You can write the right function. I mentioned the function part of the name here. It means it's a callback. So you set a write callback to curl when you want to download something. You set a read callback, you want to upload something. And here's the curl timeout milliseconds. The longest time you allow the transfer to take before it should return an error. Timeout after this many milliseconds. Ideally, perhaps not too short, because maybe sometimes the transfer will be slower than usual, but you will still accept it. So let's set it to 5 seconds. This should be completed within 5 seconds, and if it's not, it's an error return. So then you set that to 5,000, and it'll never take more than 5 seconds, or whatever value you think is appropriate. The same thing is connect timeout, MS. That's also how many milliseconds you will allow libcurl to spend trying to connect to your target server. Just the connect phase. So maybe it should connect within 2 seconds, otherwise it's a failure. So just set this to 2000 and it'll return failure if it can't connect to the target within 2 seconds. And as I mentioned, there are over 300 options available. You read up on it, and you can Google it, read the documentation. There are lists of all the options on the site. You can read up on, sort of figure out exactly when you want to use which options, reading everything curl and other indexes. Also, you will find that all man pages for these options have detailed also see also sections, so you can find relevant related options. Of whatever option you read about, you can find related options that maybe you would be interested in as well, if you were interested in that option and so on. And of course, as I mentioned, all man pages have examples as well, and the examples might then also use other options that you might be interested in and so on. So anyway, you set those options, you have set a URL, some callbacks, timeout maybe, and then bam, ask the transfer to get done. Curl easy perform. It will perform the entire transfer until it's completed. And by completed, it's not necessarily with success, right? Because maybe something goes wrong, then it'll return as well. So this either makes the entire transfer and returns okay, then the transfer completed the way it was supposed to do, or it's returned an error, and then it's a non-zero result here in the curl code variable. And there are, I think, about 100 different error codes that explains what the problem was if anything went wrong. So if you want to convert this into a actually real live source code, how to do, remember, you only need one header file when you write libcurl API using code. We only do include curl/curl.h. I once upon a time considered doing it differently, but I sort of scrapped all the other ones. So nowadays you only include this header file when you work with libcurl, and it should always be enough. You don't need anything else. You should never do anything else. And so the very minimal, easy file transfer example is I mentioned you create the easy handle first. You need a handle, and then if you for any reason would not have enough memory or something, that will return an error, right? So then, sorry, it will return a null pointer. So in this case, our example checks, did we get a valid pointer back? Otherwise, something is seriously wrong. Let's not go there. So we got a URL easy handle. We set the URL for it. We ask it to follow redirects, curl up to follow location. And the capital L there, 1L, is because it's so long. So it emphasizes and tells the compiler this is a one set as a long type. And then we do the perform. We do the transfer. And in this case, it gets https://example.com. And that might be a redirect to a different URL. But we've asked curl to follow redirects. So it could follow redirects. It actually can follow several redirects. There is an internal maximum, but that's fairly high. So it will follow several redirects if there are any, and then it is completed. And since we didn't specify a write callback here, where does the data go? It will just get sent to standard out, which is rarely what you want, but it'll do this anyway because that's the default. And if it returned something else, then okay. I mean, if it returned an error, something didn't work. Maybe we misspelled the host name. Maybe example.com won't resolve or anything. Then we can output an error. Then we have this convenient curl easy str error in the str error sort of standard. This function will return a human readable error message for the input error code. Basically, couldn't resolve the host name or couldn't connect to the host or any number of different, not any number, but there are 100 different reasons. Some of the reasons, of course, cannot happen for some of the protocols and so on. So you can also provide the curl opt error buffer option to libcurl to get a more specific, more verbose error message for your particular error. This curl easy just gives you the generic string for a particular error code. And then once you're done with the entire transfer, you don't want to do any more transfers with this handle. You call curl easy cleanup, bam, no more transfer. Then that kills the handle, right? Freeze all the memory, all the resources, don't use the handle again, and we're done. That's a very minimal using the easy API and file transfer example. I got the question if libcurl can support SSL on Windows CE 5. I'm not sure if I'm not really up to this Windows CE things. I remember recently, well, a while ago, I worked with a customer doing libcurl on Windows CE, but then we, of course, made sure that we built a custom TLS library for Windows CE as well that we used. We used wolfSSL in that case to make sure that we get a modern TLS, because some of those slightly older Windows and Windows CE machines, they have really ancient SSL and TLS support, which makes it really not usable, at least on the wide internet. But I can't remember the exact details, which version numbers and everything. So I don't know for sure if that was CE5 or something else. Moving on. So go ahead and ask questions and interrupt me if there's anything sort of not clear or anything. So just the steps again, then I want to sort of just emphasize, because this is a common pattern in curl, in libcurl in general. You're in it, get a handle back, you do setup, set all your options, you do the perform to do the actual transfer, and when you're done, clean up. And ideally, you do more performs per handle. So the more, if you want to do 2 transfers, 3 transfers, anything, reuse the same handle, because that handle also keeps caches and stuff around that makes subsequent transfers much faster, especially if you want to transfer do a second transfer to the same host name. The connection might still be alive, for example, so we can reuse the same connection. So the second transfer will be instantly done, because the connection is already there. So you don't have to set it up. You don't have to do any name resolves and TLS handshakes and everything. So that is how you do transfer, right? So when you want to get data, as I mentioned, you do the write function. That's a write callback. It looks like this. It's a write callback. You get the contents, you get the size in a slightly peculiar way. This is because this is made to mimic the f write function. So you get the size and the element. They actually like that. The real sizes actually multiply them together. You should read up the documentation, because one of them is always 1. And the data is what contents point to, and the user P there, the 4th argument to the callback, it's what you set with the option curl up to write data. So it's whatever you want. Could point to a struct of yours or anything you want. Curl doesn't care about that. It'll just pass in whatever you told curl about. And then when you're done with your write callback, you return the amount of bytes you dealt with, which should be the same as you got as input, right? Because if you didn't deal with all of them, something is wrong and curl will report an error. And if you want to send data, there are a few different ways actually to send data. Mostly, for example, if you want to do an upload, you could do it with a read function, that's a callback. But if you want to do basic HTTP post, for example, there's an option called post fields that points to a string to send. Or you can do the MIME post, which is a more complicated multi-part form post. It's doing a MIME thing for you to do transfers. So when I do a post example, for example, HTTP, you do the same thing. You set a URL. You can set this string post fields. I want to send hello to the server, and then do the transfer, and blah blah blah. Everything's there. So this then, instead of doing a download here, this made actually an upload, but it's an HTTP post. It sends those 5 bytes to the server. And when you've done a transfer, you want to get info back, right? And then you have the curl AC get info, which asks the curl handle about data that the curl handle has kept from the previous transfer. For example, you can ask which was the final URL you got to when you asked it to follow redirects. For example, I showed you the example before. So which was the last effective URL that you got the transfer from? Tell me, which was the HTTP response code from the transfer? How long time did it take? Which speed did you download this with? Or what was the content type header from the most previous transfer? And lots of more. I think there are almost 60 different variables like this to extract, even more perhaps. And we're adding more every once in a while. So there's a lot of information to extract from the previous transfer. Like this, you do the transfer, it completes, and if it's okay, you extract something. Like in this case, get the content type from the previous transfer. And then you get a pointer back in the CT variable here, and you can output it. We got this content type. Kind of handy. If you want to get other HTTP headers, there's actually a dedicated header API these days that is even more convenient. So I would recommend using that. But I'm not going to get into that today. So when things go wrong, you read the docs again. Okay, why doesn't your file transfer application do the things you want to do? Of course, you want to read up, did I actually understand all the options of the functions again? Make sure that you check the return codes from the libcurl functions. I often, when I write examples here, I don't always add error code checks in the examples, because it's mostly to make the examples a little more concentrated and succinct, so that you just see the libcurl function calls. But you should always verify that they return what you suppose they should return. That is okay. And if they still do, try with a verbose option first. Figure out what it says. Does it output warnings? Does it look okay? Does it say something crazy? And provide an error buffer to get a more detailed error message when something goes wrong. And when you want to go even further, check out the debug function callback, which allows you to get even more detailed tracing and logging of pretty much all the protocol magic happening under the hood. And you get all of that sent to callback, and you can output that, and it gives you an even more detailed log. And of course, always when you write C programs, and you do that on in particular on Linux, but who wouldn't use Linux for this? Use Valgrind. It's really your friend to make sure that your program is not doing anything crazy memory-wise with pointers and memories and everything. libcurl itself will, of course, never find you or show you any Valgrind errors or have any error sort of memory problems, only when we have serially messed up. And of course, you can always get help. We have free support on the curl mailing list. You can just go there, ask whatever question you want about libcurl, how to use it, how not to use it, or if you have problems, you file a bug report. And we're always around at wolfSSL to give you commercial support, of course, if you want to have it even faster, maybe deal with your private details off the public, or even better response times and everything. So that was the easy interface. Easy blocking synchronous file transfers, they go all the way until they are done. But what if you want to do more than one transfer? Maybe if you don't want it to be a blocking transfer, sort of a blocking call until it's done. I mean, maybe you don't want it to be blocked for many seconds and then return. Then for all those use cases, we have the multi interface. It performs many concurrent non-blocking transfers in the same thread. So this is not using multiple threads, it's still the same thread. It's very important because, yeah, you know, threading is complicated. Not using threads is less complicated. So you can also then add and remove transfers, I mean, during in progress, really. So you can, for example, you can add a bunch of transfers, do them, and then you can add more transfers while the others are going, and you can stop some transfers while the others keep going. It's perfectly doable and supported. And it leaves the event loop to the application, so the libcurl will then not wait on the sockets or anything. You will do that for libcurl. So you create and set up easy handles, just one for each transfer that you want to do, exactly like before. But now you might do more than one easy handle, right? You can do 2, 3, 4, 5, 100 easy handles because you want to do them all in parallel. And then you create one multi-handle. The multi-handle is the home of all the easy handles. So you then add easy handles to the multi. Here's a multi-handle. The multi-handle will take care of your transfer for you. Add all the transfer to it that you want to do. Add them. 1, 1, 1, 1, 1. And then you drive all the transfers in parallel with a single function call, and it'll then drive all the transfers at once, or sort of concurrently. So it works like this. So in this example, we make two parallel transfers. We have an easy handle and an easy handle 2, both created with easy init, like I mentioned before. You set options. In this case, we just do 2 different HTTP, one HTTPS, one HTTP. We want to download them both at the same time. So we set options. I don't set any other options because I want to keep the example simple. And then we create a multi-handle. The multi-handle is what we will sort of use to drive all the transfers. But first, we want to add the individual transfers to it. So we add curl multi-add handle. That means we add the easy handle to the multi-handle. Put it into the multi-handle. First the easy handle, then the easy handle 2. So we added 2 easy handles to the transfer. We want to do 2 transfers in parallel. And now we have a little, so we do while loop while we have transfers still running. And at this point, we just assume that we have, right? Because we have just started. We have not even started, but we start them with the first call here, right? So curl multi-perform, do as much of the transfer as you can and then return. So this will not complete the transfers. It will just do a little bit of transfer stuff and then return. Before it needs to wait and before it gets blocked or anything, return. So typically this will just, you know, run for a few milliseconds maybe and then return. Still running will say 2 because there are 2 transfers still running. So if we still have 2 transfers, or we still have any transfer running, we'd say curl multi-poll, wait for anything to happen on the underlying sockets transfers, or timeout after 1. That's the 4th argument here, says 1000. That's a timeout in milliseconds. So if nothing happens in 1000 milliseconds, return anyway, because it helps us. We can output a progress report or a progress meter or something. And if there's an error, get out of here. But if it's not, if we returned from the multi-poll, we might have data on a transfer. And if we got data, maybe the transfer is completed. So we ask curl if there's an info to read. So it has a sort of a communication queue that it reads from. And if it gets data, it can check, is a handle done? If it is done, the transfer is completed. Since we do many transfers in parallel here, we need to figure out if one of them has completed in this single loop. And if one of them has completed, this is how it's told. And then that loops around the incoming queues, in message queue, right? Because it could be one for either, both could end at the same loop, or maybe not. And if we still have if we still have transfers running, it will then just loop up to do the curl multi-perform again, drive the transfers a little bit more, and then wait for more then go into multi-pole, wait for activity on the sockets, loop. So this will then drive both of the transfers until they both complete, and then it exits the loop. Then we remove the easy handle again, both of them from the multi-handle. We clean up the multi-handle, we can clean up the two easy handles, and both those HTTP transfers, the HTTP and HTTPS transfers, have been completed in parallel. Yeah. And of course, you can add and remove transfers in that loop at any point, and you can mix and also wait for your own file transfers. You can set a lot of different options with curl multi-setup in the same style, because you have a multi-handle, and that you can do setting options for multi-setup. And if you want to go event-based, which is even more, if you want to go really high end, if you want to do, let's say, thousands of parallel transfers, you want to go with a multi-socket action instead, because it's more high performant for a larger amount. At least when you go above, let's say, a few hundred concurrent file transfers, you want to switch to the event-based one. Yeah, and on threading, libcurl is single-threaded pretty much all the way. Everything you do will be in the same thread. You start it and you get all the callbacks in the same thread. It will return in the same thread. Everything is in the same thread. That little asterisk here is because the name resolving thing might use a helper thread, but that's really not of your concern. It's going to happen in the background, but it might be started and killed by libcurl itself. It will not call any callbacks. It will not sort of affect you really, but we need to do a separate helper thread to make sure that we can time out properly from name resolves. Otherwise, they're all in the same thread. You can do many threads and do individual curl easy perform in separate threads as much as you like. I mean, you can fire up hundreds of threads and do file transfers in each of them if you want to. I'm going a little bit longer than I intended to. I guess I'm talking more than I planned, but do feel free to ask me anything. I just wanted to, as a sort of I did almost this same webinar 2 years ago, and then I did not mention anything about the URL parsing, but the URL parsing is really a newcomer into the curl API family, really. So it allows you to parse URLs easily. You as in your application. And when we talk about URLs, there are many different ways to, I mean, what is a URL these days? That's a tough question, but from our point of view, a URL is one that is specified in the RFC 3986. I call it 3986 plus because curl has some tiny extensions that goes beyond the RFC, mostly to make sure that it interacts better with how things are done on the web. So this is not the same URL specification that the browsers are using, meaning that there are a few deviances. So sometimes curl and the browsers disagree on what the URL is and how it should do, which is unfortunate, but life. So with the URL API, you can parse, change, generate the URLs, and I'll show you how easy it is. Then we have this curl U handle that represents a URL in the same style. It's another opaque handle. It'll just, be a handle to a URL. You create a URL, one of these URL handles, with the function curl URL. Crazy name, right? Basically, yeah, right. You can also duplicate one of those URL handles. So basically, you set URL parts to a handle if you want to add them to the handle, and you can get URL parts. You follow pretty much the same style of API and approach, like I talked to you about the easy interface. So you, for example, here's a URL, well, all the crazy parts of URL. So all of these different parts, scheme, user, password, host, port, path, query, fragment, are different components, and you can refer to them in a URL called using this curl U part name. So and there's a URL for the entire thing. So basically, so you can parse a complete URL by setting a URL into the handle, and you can get the URL by sort of getting individual components of the complete. I'll show you. In this example, we can go from the top here. It creates a curl U handle with the curl underscore URL function. You set the curl U part URL. I mean, you set the entire URL. You ask curl to parse the entire URL for me. And then after that, you can get individual components from the parsed URL. In this case, it gets the curl U part underscore URL, which is the full URL. It extracts the full URL again from the URL object, and then it frees everything. But it could also get just the host name, the port number, the path, or the fragment, or whatever you want to do. So you can then also set individual, you don't have to set the entire URL at once. You can set a different component. You can set the host name, port number, scheme, and then get the full URL out of that. For example, like this. This sets this, if you go from the top, it creates the curl U handle, it sets the scheme, it sets a host, it sets a port, it sets a path, and then it extracts the entire URL out of that. Which means that if you run the program, in the bottom here, you see the full URL created by those 4 components that were set individually. And the same way, you can extract components like that, right? You can set the entire URL and then extract, like in this case, the port and the query part from the URL, and bam, you extract that. You get a complicated URL in, you extract the individual components using the URL API. It can also help you to for example, do a redirect from one URL to relative URL. In this case, you set the full absolute URL, and then you have a second redirect URL. You want to go to ... blah, 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 and you set the second URL as a relative one, and curl will then figure out the absolute one for you. And you can also do URL encoding, which means, you know, the percent thing, %20 for space, %3f, all sorts of things. And you can even do international domain names, and then you just tell curl, I want you to manage. By default, it will do. It handles both encoding and decoding. So in this case, the first can encode to Punycode. In this second case here, can decode back to international domain names. I'm going a little bit fast here because you don't really need to figure out all the details. I'm just mentioning here that these are features you can use if you want to. They're there and they're tested. And really, there's a lot more to say about the libcurl API, of course. I want to highlight this little video I made. This is actually part 1. I actually made 2. They're called Mastering libcurl. Go to YouTube and just Google for them on YouTube. No, search for them on YouTube. Mastering libcurl. They're part 1 and part 2. That's more than 3 hours of video in total. I'm going through a lot more details about libcurl and using libcurl and everything. So if this webinar was not enough, that's going to take you even further down into the weeds about specific details. And as I mentioned, Everything Curl, the book, has a lot of details and a lot of examples and stuff on all of this. So basically, this is what I wanted to say to you. So fire away to your questions. If you need curl support commercially, of course, come contact us. And it is open source, so come help us out if there's anything that is wrong or bad or needs improvement or anything. So if I mentioned configure CMake. Yes, it means that we keep more than one different build system up to date. We keep at least 3 different ones up to date. So yes, it's a little bit unfortunate. It's a lot of work, but the good part with it is that we can provide different build systems for those who prefer different ways of building. So you go with whatever you choose. They are not always on parity with each other, so sometimes one of them is a little bit better than the others, but the plan is to make sure that they all do what they are supposed to do. So you should just be able to go with the one you prefer.
And there's another question. How do you build libcurl on Windows?
Yeah, so on Windows, preferably you go with CMake and you generate Visual Studio or make files, because CMake is probably the most modern way to do build on Windows. Otherwise, we have two other ways too. So either there's also WinBuild directory in the source tree where you can go in and run and build libcurl with the nmake just from a command line. And we also generate actually Visual Studio project files that are available, so you can import and build directly from within Visual Studio. So, and there are also these days package managers like VCPKG, right? VC package or Chocolately and things like that are actually package managers that can provide libcurl rebuilds for you as well.
If there's no any question, then thank you, Daniel, for hosting the informative webinar and everyone for joining the webinar today. Please don't forget to follow us on Twitter at WolfSSL as well as other socials. If you have any further questions, please email us at facts@wolfssl.com. And thank you again and see you next week.